Dear children, in this lecture, let's discuss the sixth problem from exercise 5.2. We are asked to find the derivative of cos of x cube into sine squared of x power 5. Let's assume the given function to be y. Let y is equal to cos of x cube into sine squared of x power 5. So which is in the form of product of two functions. So let's call them as u of x and v of x, wherever u of x is equal to cos of x cube and v of x is equal to sine squared of x power 5. So, our y is of the form u of x into v of x. So, the derivative of y dy by dx is given by d by dx of u of x into v of x plus u of x into d by dx of v of x, and this follows from the product rule. So let's call this as 1. We shall compute d by dx of u of x, d by dx of v of x, and substitute in equation 1. Now, we have assumed u of x to be cos of x cube. Let's explain the chain rule for differentiating this. So let f of x is equal to or we can take f of r is equal to cos r, where r is equal to g of x, that is equal to x cube. So, our u of x is the composition of two functions g and f, that is f of g composite f of x, that is equal to f of g of x. So this can be the derivative of u of x, d by dx of u of x is going to be f dash of g of x into g dash of x. This we get by the chain rule. So from this we get f dash of r is equal to minus sine r, that is f dash of g of x is equal to minus sine of x cube, and from this we have g dash of x is equal to 3x squared. So d by dx of u of x becomes minus sine of x cube, that is f dash of g of x, into g dash of x, that is 3x squared. Similarly, now let's compute d by dx of v of x. We have v of x is equal to sine squared of x power 5. V of x is equal to sine squared of x power 5. So let's make appropriate assumptions. F of r equal to r squared, where r is equal to g of s, that is equal to sine s, wherever s is equal to h of t, oh sorry, h of x, where s is equal to h of x, that is equal to x power 5. So the given function v of x can be written as the composition of three functions: h composite, g composite, f of x, that is equal to f of g of h of x. So by the chain rule, the derivative of v d by dx of v of x is equal to f dash of g of h of x into g dash of h of x into h dash of x. So this, from this assumptions we get f dash of r is equal to 2r. So this implies f dash of g of h of x is equal to 2 times sine of x power 5. And from this, g dash of s is equal to cos of s, that is g dash of h of x is equal to cos of x power 5. And from the last assumption, we have h dash of x is equal to 5x power 4. So from this we get d by dx of v of x is equal to 2 into sine of x power 5 into cos of x power 5 into 5x power 4. By using trigonometry identities, 2 sin a cos a is sin 2a. So it is 5x power 4 into sine of 2x power 5. Or it could be simply kept as 10x power 4 into sine of x power 5 into cos of x power 5. As the answer demands, we can use any one of the two forms. So making these substitutions in equation 1, or from equation 1, we have the derivative of sine squared. The question is cos of x cube into sine squared of x power 5. Therefore, the derivative of cos of x cube cos of x cube into cos of x cube into sine squared of x power 5, that is equal to derivative of cos of x cube, that is 3x squared minus 3x squared into sine of x cube minus 3x squared into sine of x cube into v of x, that is sine squared of x power 5 plus u of x, that is cos of x cube into dv by dx, that is d by dx of sine square of x power 5, that is 10 x power 4 into sine of x power 5 into cos of x power 5. This application of chain rule, we should be able to do directly without making these assumptions. So in applying the chain rule, first we have to differentiate the exponent. So differentiating sine squared, we get 2 sine, the same argument x power 5. Next, differentiating sine, we get cos, the same argument x power 5, and differentiating x power 5, we get 5x power 4. We should be able to do this calculation directly without going through these steps. We have made these steps for better understanding. In the next lecture, we will continue with the 7th problem.